Hello everyone, and welcome to Biopedia. In the process of ordinary meiosis, the creation of gametes, gametes are supposed to end up with one copy of each chromosome. After chromosomes replicate, the first round of meiosis is supposed to move different homologous chromosomes into daughter cells, while these homologous chromosomes then again separate into individual chromosomes in the final daughter cells. However, this process of separation can sometimes go awry. Specifically, non-disjunction causes chromosome pairs to remain associated with one another and not separate. As a result, some gametes end up with two copies of a chromosome, and, when fertilization then occurs, the resultant zygote has three copies, where it would normally have two. This is known as a trisomy. Now, the severity of different trisomies varies. For example, trisomy 21, Down syndrome, is not fatal. However, most babies which inherit trisomy 18, or Edwards syndrome, usually tragically don't make it past their first birthday. A quick note here about Edwards syndrome, as the picture is more complicated than the simple one of non-disjunction we've discussed so far. Specifically, there are three types of trisomy 18. Full trisomy 18 is that simpler picture we mentioned just now, with the cell simply having too many full chromosomes. However, there are two other forms. Mosaic trisomy 18 refers to some cells having the trisomy, and some cells having just two copies. And partial trisomy 18 means that only part of the longer arm of chromosome 18 has three copies, rather than the full chromosome. But with that out of the way, I'm now going to spend most of the rest of today's episode focusing on a study published in the International Journal of Environmental Research and Public Health in 2020. This study centered on a fire in a warehouse in Bryan, Texas on the 30th of July 2009. This warehouse stored fertilizers, which decomposed in the fire to form products such as nitrogen, nitrous oxides, and ammonia, as well as several halogen compounds such as ammonium chloride and hydrogen fluoride. Now, epidemiology studies suggest that exposure may be correlated with human chromosome number abnormalities. As such, the study examined all live births from 2005 to 2014 in Brazos County, the area where the fire took place. These births were examined for chromosomal irregularities such as trisomies 18 and 21. The period from 2005 to 2008 was considered as being the period before the fire, 2009 to 2010 as the period when the fire may have had an influence, and 2010 to 2014 was classified as after the fire. Their results suggested that trisomy 18 did significantly increase during the period of the fire. Whereas the incidence had been 0.19 per thousand before and after the fire, it increased to 1.3 cases per thousand in the years when the fire had an impact. By contrast, trisomy 21 incidence didn't significantly change, going from 1.3 per thousand and rising to 1.4 per thousand during the accident years, before ultimately falling again to 1.2 per thousand. And while this is a change, it was not statistically significant. When comparing Brazos County to the rest of Texas, the authors found that the risk of Edwards syndrome was significantly higher from 2009 to 2010, but not for the other years studied. By contrast, and in keeping with the results mentioned above, trisomy 21 risk was not higher than the rest of Texas before or during the accident. In fact, it actually significantly decreased after the accident compared to the rest of the state. The authors concluded that it is possible that the accident was related to the increased Edwards syndrome incidence/risk observed in Brazos County, Texas. So, just to sum this up, this shows that, while trisomies are definitely genetic in origin, they may still be influenced by the environment as well, such as in the case above. As always, thank you for listening. Feel free to get in touch with the show's email address for any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.